All right. Good afternoon, everyone. Welcome to our physical science class. So, our topic for today will be atomic number and synthesis of new elements. So, we have three objectives for today's lesson. First, define atomic number. Second, determine the atomic number and mass number of the given element. And third, explain how the concept of atomic number lead to the synthesis of new elements in the laboratory. So, we have here a list of words that we're going to use in answering the concept map. So, here is the concept map. So, we have the stellar nebula, in which is a collection of dust particles. And then we have the protostar. And then after the birth of the star, it will be a main sequence star. It can be a low mass star and massive or high mass star. So let's start with the low mass star. So what happened with the stars that will become a low mass star? So it will become the red giant after some series of processes and events. The red giant will become the planetary nebula, and then after some years, the stars from planetary nebula will become the white dwarf and black dwarf as they die. Next, when the star will become a high mass star or a massive star, the star will undergo processes that lead to become a red supergiant. So after the red supergiant, after billion of years, if the star will going to die, it will go or undergo the process of supernova, in which the explosion of the stars. So after the explosion or the death of the star will become either neutron star or black hole star. So this is the concept map of stellar formation and evolution. So what do you think are the words that we can form in this picture? What are the two words that we can form in this picture? Alright, correct. We have atomic bomb and then atomic number. So today, we're going to discuss the atomic number of an element. So in 1914, Henry Moseley arranged the elements in periodic table based on their increasing atomic number. As highlighted in my presentation, the periodic table of elements is arranged based on the increasing atomic number. The atomic number is refers to the number of protons in an atom's nucleus. It is also the basis of elements' identity. So up to this date, Henry Moseley's work is very significant because the elements are still arranged in terms of atomic number. It also the basis of elements' identity. Moreover, the number of protons in the element determines the electrons that surrounds the nucleus. The atomic number of an element helps the scientists to synthesize new element in the laboratory. So I have here a question. What is the essential role of atomic number in creating new element? So we're going to find the answer with this question as we finish discussing our topic. Atomic number and atomic mass. Henry Moseley experimented with X-ray tube by changing the metal used for the anode. He measured the wavelengths of resulting X-ray, and each different metals is made its unique kind of atoms. Each element's atom have characteristic number of proton in the nucleus. So this is the process on how Henry Moseley arranged the periodic elements by the increasing number of atomic number with the experiment of X-ray spectroscopy. So we need to remember that neutral atom, if an atom is neutral, the number of proton is equal to the number of electron. Thus, atomic number is equal to the number of electrons in a neutral atom. So for you to easy to understand what I mean is, for example, you have an element with a symbol of B. So this element will be boron. Okay? The element is boron. As you can see, there is no charges with this boron. So, meaning, this element is a neutral atom. There is no charges. What do you mean charges, ma'am? So, when we say charges, it can be seen in the upper right corner of the element. It can be a positive or negatively charged. So, as long as you will not see any charges at the upper right part of the atom or a symbol, it will remain as neutral atom. Again, as long as you will not see any charges at the upper right corner of the symbol of an element, it will remain as neutral atom. Alright. Meaning neutral is a stable atom. Okay. So here is a symbol that we used in determining the atomic number, atomic mass, and the symbol of an element. So we have here letter X. X stands for the element symbol. So for example, the element symbol for hydrogen is letter H. Next will be the letter Z. Z stands for the atomic number of an element. So the atomic number of an element will be seen in the periodic table. So for hydrogen, the atomic number of hydrogen is 1. Number 1. Next will be letter A. When we say letter A, it stands for the atomic weight or the atomic mass of an element. So, usually, we can see the atomic mass or atomic weight of an element below the symbol of the element. So, if you are using the mobile application, you can click the hydrogen and it will be directed to the general properties of the element. So you can see in the application, mobile application, or in the periodic table, the standard atomic weight. So based here in my mobile application periodic table, the atomic weight of hydrogen is 1.007. But I will going to round off the atomic mass or the atomic weight. So letter A will be 1. Okay. So how can we know or how can we determine the atomic mass? If ever you don't have any periodic table with you, you can still find the atomic number of an element or atomic mass of an element. Okay, so the formula will be the number of proton plus number of neutron. So, or atomic number plus number of neutrons. So, how can we know the atomic number of an element? So, again, the atomic number of element can be seen at the top left corner or at the top center of the element. So for neutral atom, the number of proton is equal to the number of electrons and equal to the number of or atomic number. For example, we have helium. The atomic number for helium is 2. So here, we have atomic number is 2. The atomic weight for helium, let us check it. Okay, helium. Base here in the periodic table, the atomic weight for helium is 4. So, atomic weight is 4. How about the proton? So, again, proton is same with the atomic number of an element. So, the atomic number of helium is number 2. How did we get the proton? We get the proton by copying the atomic number of an element because atomic number is equal to the number of protons. How about the number of electrons? In a neutral atom, the number of proton is same with the number of electrons and also same with the atomic number. So we're just going to copy the number of proton. So we're going to put number 2 because they are the same, right? And for the last one, neutron. So how can we get the neutron of an element? So based here, the number of neutron is equal to the mass number minus number of proton. So we have the mass number, we have 4. So 4 minus the number of proton, we have 2 protons for helium. The answer will be 2. So the neutron of helium is 2. Alright? So if you'll find difficulties in understanding this part, please replay this part and listen again on how I discuss and get the number of proton, electrons, and neutron. Alright, so remember, we have protons. These are positively charged ions. Electrons, these are the negatively charged ion. And the neutrons are the neutral or no charge. So always remember these 3 words. So this part, I use this in the discussion for tycoons. So as you can see, these names are the names of the students from tycoon. So just disregard this one. So I'm going to give you more example on how to determine the atomic number, element name, element symbol, and mass or atomic weight of an element. Alright, so let's start with the atomic number for the number of electrons. So first, again, for the neutral atom, the number of electron is the same with the number of proton and the atomic number. Again, number of electron is same with atomic number and proton. So we're just going to copy the number of electron because they are the same atomic number. So 3, 13, 23, 33, 43, 53, 63, 73, 20, 31, 18, 28, and 40. I do apologize to my penmanship. So, these are the atomic number of the given element. How did we get that one? We get the atomic number of element based to the number of electrons provided in the presentation. So again, we have the atomic number based to the number of electrons given in the presentation. So how would we know the element name? So all you need to do is look at your periodic table and then look at the number or the atomic number of each element. So number 3. So look the element number 3. So it's lithium. So it's lithium. And how about the symbol? It's big letter L and small letter I. So what is the atomic mass or atomic weight of lithium? Kindly check your periodic table. We have here 6.9. So as was I say a while ago, you need to round off the atomic mass or weight of an element. So here is 6.9, it will be 7. Again, you need to round off the atomic mass or weight of an element. So let's proceed to atomic number 13. So atomic number 13 is aluminum. So the element symbol for aluminum is La. The atomic mass for aluminum is 26.9. So you're going to round off that number. It will be 27. Next will be 23. Element number 23 is vanadium. So vanadium with the element symbol of V has atomic mass of 50.94. So we're going to round off and make it 51. Next, atomic number 33. Atomic number 33, the element will be arsenic. So arsenic, the element symbol for arsenic is As. How about the atomic mass for arsenic? We have 74.9, so we're going to round off it. We'll make it 75. Again, we need to round off the atomic mass or atomic weight of an element. You can see the atomic mass and atomic weight of an element below the element symbol or at the side. It's usually decimal point. It is written in a decimal form. So next for element number 40, element number 43. Wait, I will just check the element number 43. So 43 is titanium or Tc. Atomic mass is 498. Then let's go now to element number 53. Element number 53 is the iodine or iodine. So element symbol is I. The atomic weight is 127.6. So we're going to round off 127 to 128. Alright. So you just continue to look for the element symbol in the periodic table and then the atomic mass. So use this given atomic number as your exercises for you to better understand on how to find the symbol of the element, then atomic mass of the element. Right. So I have here a seat work number 1 or activity number 1. All you need to do is to determine the number or determine the atomic number and predict the name of an element. Same with my examples a while ago. So, please attach this one in your Google Classroom later. So, here, I have here, fill in what is missing in the SciPen table. As you can see, it is already answered because we answered it a while ago in the discussion with the Tycoon student. So, when we say SciPen table, Z stands for atomic number, A is for atomic mass, P is for proton, E is for electron, and N for neutrons. So, now, number 1, we have magnesium. Magnesium has atomic number of 12. So, kapag atomic number niya is 12, definitely they are the same with the proton. So, put 12 in the proton and put 12 for the electron. Take note, there is no charge sa symbol ng magnesium. So, the magnesium is a neutral atom. So, the proton and electron is the same with the atomic number. Right? So, how did they get 24? 24, it is written in the periodic table, the atomic mass of magnesium. So, it's 24. So, how did they get the 12? So, we have the formula, neutron is equals to atomic mass minus proton. So, 24 minus 12, it's 12. So, the neutron for magnesium is 12. Now, let us proceed to element number 2, the aluminum. So, again, aluminum is a neutral atom because there is no charge at the right upper part of an element. So, let's look for the atomic mass or atomic number in the periodic table. So, aluminum is element number 13 with atomic number 13. So, again, we will just copy 13 sa proton and then for electrons because they are neutral. You just need to copy because they are the same. The number of protons and electrons are the same with the neutral atom. So, we'll just copy the atomic number with the protons and electrons. So, again, how did they get the atomic mass or weight? They check it in the periodic table. Take note, check it in the periodic table. Please round off it. If it is 27.1, make it 27. It's 27.9, make it 28. Right? And then, how did they get 14? 14, we have the formula of neutron is equal to atomic mass minus proton. So, 27 minus 13, it's 14. So, they get the neutron by subtracting atomic mass to proton. Alright, so let's proceed to number 3, the sulfur with negative 2 charge. So, this is unstable atom. So we have a charge. This is not a neutral atom, it's an stable atom. So again, how can we get the atomic number of an element? You need to look at the periodic table. Look for the element sulfur and find what number it has. So sulfur has atomic number 16. So how can we find the atomic mass? Please check in your periodic table the atomic mass of sulfur. Please round off it. So if it's 31.9, it will be 32. If 32.1, it will be 32. Then how can we get the proton? Proton is equal to atomic number. So we'll just copy it. Proton is equal to atomic number. So we'll just copy 16. And now, let's proceed to neutron. We'll have the electron later. So how can we get the neutron? The same process. You're going to subtract the atomic mass. So the atomic mass of sulfur is 32 minus the proton. The proton is 16. So 32 minus 16, the neutrons are 16. Again, how can we get the neutron? Atomic mass minus the proton. Now, how did they find the answer for electron with an unstable atom or element? So here, all you need to do is to look what is the charge of the element. So the charge of element is negative 2. So remember, if it's negative, you need to add this charge to the proton. Again, if the charge is negative 2, you need to add the charge to the proton. So the proton of sulfur is 16 plus 2. It will become 18. Again, determine the charge of the atom. So if the charge of the atom is negative 2, add this 2 to the proton. Do not be confused with the symbol if it is negative or positive. Just always remember, if it's negative, you need to add it to the proton. And for the last number, we have the iodine or the iodine. So in the iodine, it's not a neutral atom because it has positive 1 charge. So how can you find the atomic number? Again, please look at your periodic table and find the element number 53. So the element number 53 is the iodine. So look for the iodine. It has atomic number of 53. How did they get the 127? Based on the periodic table, it has atomic mass of 127. Please do not forget to round off, alright? Next, proton. How can you find the proton? Again, either neutral or unstable atom. Atomic number is the same with the proton. Again, atomic number is the same with the proton. So all you need to do is to copy the atomic mass or the atomic number and just put it in the number of proton. Now, how can you get the neutron? Neutron, again, we have the formula A, atomic mass 127 minus proton 53. And then you can get, or you will have the answer 73. Again, you need to subtract the atomic mass to the proton. So you can have the number, or you can have the result of 74. And then lastly, how can we get the electron of this element? So we have the proton. We have 53 proton. We have this rule. If it is negative charge, you will add the charge to the proton. But if it's positively charged, you need to add this one to the, or you need to subtract this one to the proton. So you need to subtract positive 1 to the number of proton of iodine. So the number of proton of iodine or iodine is 53. So all you need to do is to subtract positive 1 to 53. So we have the 52. Again, if the charge is positive, you need to minus e to the proton or subtract e to the proton so you can have your electron. If the charge is negative, you need to add this negatively charged to the number of proton to have your electron. If you find it difficult, please replay and watch it again. Alright? So, this is the output of tycoons. You can check this one or you can have this as your guide on how to get the stipend output or stipend for each of these elements. So we have seat work number 2. Please complete the second table with the number of proton, electrons, neutrons, find the atomic number, and then the atomic mass. So the synthesis of new element. The scientists use particle accelerator to synthesize new synthetic element. Most of the elements are found naturally, but there are some elements can be produced in the laboratories. The scientists use particle accelerator to synthesize the new synthetic elements. The particle accelerator is a device used to speed up the electrically charged atomic particles or subatomic particles by using magnetic and electrical fields. So remember, the particle accelerator is a device used to speed up the electrically charged atomic particles. So they are using the magnetic and electrical fields. So what are they using in particle accelerator? They are using the magnetic and electrical fields. So they can accelerate or speed up the electrically charged atomic particles. So in 1930, the element 92 or the uranium was the heaviest element discovered that time. So in 1930, you cannot find any element beyond 92. So there is no 93 to 118th element. On that time, we only have 92 elements. By the year 1937, Ernest Lawrence used linear particle accelerator. So it is same with the particle accelerator, but it is specifically it's linear. In creating element 43 by bombarding the atoms of number 42 with fast-moving electrons. So he named this element 43 as tectinium. Tectinium is the first man-made element. Please take note of that. The first man-made element is the element number 43, the tectinium. In 1940, the element astatine or astatine with atomic number of 85 is synthesized by the collaboration of three great scientists. Please take note of these three great scientists, Emilio, Kenneth, and Dale Corson. They used a particle accelerator by bombarding the atoms of element bismuth with atomic number 83 using the fast-moving alpha particle. In the same year, 1940, Edwin Macmillan used particle accelerator to bombard uranium with neutrons that led him to discover the element with atomic number 93. So in 1940, 1940, Edwin discovered the element 93 and he called it as Neptunium. In the late 1940, we have the four scientists, namely Glenn, Edwin, Joseph, and Arthur, synthesized element 94 by bombarding the uranium with the deuterons in the cyclotron. When we say cyclotron, it's a particle accelerator used in alternating electric field to accelerate particles that move in a spiral path in the presence of magnetic field. So, cyclotron is also a particle accelerator. The unique characteristic of cyclotron is the particle is moving in a spiral path. Again, the particles is moving in a spiral path. So that's the unique characteristic of cyclotron. But they are the same as particle accelerator in which they are speeding up um, speeding up the electrical charge of an element or atom. The deuterons are particles made of a proton and neutron. So again, the deuterons are particles made of a proton and neutron. They name the element 94 to plutonium or plutonium. In the periodic table of elements, elements with atomic number higher than 92 are belong to the group or family of transuranium elements. Again, 92 beyond, they are belongs to transuranium element. These elements are unstable and radioactively decay into other elements. The transuranium elements are created using nuclear reactors or particle accelerator. The particle accelerator are used to create new elements in the laboratory. These elements are synthesized in the laboratory and considered as a synthetic element. So all the elements from 93 to 118, they are considered as synthetic elements. So to wrap up today's lesson, we've discussed the atomic number. So again, atomic number Atomic number refers to the number of protons in an atom's nucleus. So we also discuss on how to find the atomic mass of an element, the number of protons, the number of electrons, and then the number of neutrons. So we also discuss the things in which how the scientists synthesize or produce a new elements. So we need to remember that the elements from 93 to 118 are belong to the transuranium family and they are considered as a synthetic element, right? So we've discussed different names of the scientists who created the new elements. Right. So, what is the essential role of atomic number in creating new elements? So, it is important to know the atomic number of an element. As I have said a while ago, periodic table is arranged based on the increasing number of atomic number. So, this arrangement is based on the experiment of Henry Moseley with X-ray spectroscopy. So we need to know this one because atomic number is one of the responsible in synthesizing and creating the new elements. with the use or with the help of particle accelerator. Alright? So you have an assignment to answer. So fill in what is the missing in the stipend table. Use a separate sheet of paper for your answer. But don't need to have the separate sheet of paper. You can answer it using the Google Docs or the Microsoft Word. I want to correct this one. This is not 25. It's 16. So please answer the assignment and attach it to your Google Classroom. So we have the schedule of activities. So last week we discussed stellar evolution and formation. March 31 we have the performance task, and this performance task will be passed on April 16, 5 p.m. And for this week, April 5 today, I've discussed the synthesis of new elements and how to find the atomic number, atomic mass, protons, neutrons, and electrons. And on Wednesday, I'm going to discuss the nuclear radiation, the nuclear equation, the alpha, beta, gamma decay of an element. So after the short discussion of the nuclear radiation, you're going to have your first summative test. So you're going to answer the summative test in your asynchronous time. So what are the pointers to review? So we have the three lessons: the stellar formation and evolution, synthesis of new elements, and then the nuclear radiation that will be discussed on Wednesday. So we have identification, multiple choice, fill in the missing stipend table, finding the result of nuclear reaction, and then essay. So your summative test will be 60 points. Right. So thank you very much for listening, ABM accountants. And please, if you have any concerns and queries about the discussion, you can replay this video discussion, or you can just message me and ask me about the concept that you find it difficult. All right, thank you for listening.